Hello. So this is our first video. We'll probably do a few just so that people can jump to the video that they need in particular, but we're going to be going over the functions assessment for those that need potentially any corrections people can get from this, as well as, obviously some additional learning that might need to occur, but this is going to be kind of step one for fixing that assessment. So the first part of the assessment, I've given you two different functions and asking you to determine the following values. So depending on what it looks like, this f of 4, we're simply going to plug 4 into my expression and kind of evaluate it from there. So it's looking like we're going to get 28 once all is said and done when I evaluate that. 4 squared, 16, times 2 is 32, minus 4 gives me 28. G of 3 means take 3 and plug it into this expression. And if I crunch that, 18 minus 4 is 14, divided by 2 is 7. This expression is saying take -1, plug it into G, and kind of get a result first, and then take that result and plug it into F. So if I kind of do this piecewise, or, piecewise is actually a thing, so I might not use that word, but if I do this bit by bit, 6 times -1 is -6, minus 4 gives me -10, divided by 2, so this is -5, and then I'm looking to figure out what f of -5 is. -5 squared is 25, so do the exponent first, times 2 is 50, minus 4, getting 46. This is notation for the inverse of G. So I'm going to jump a few steps and just write this like this. So normally if we're finding the inverse, we replace g of x with y, and then our next step is to swap x and y. So if I do some slight fast forwarding, I end up here. And then if I am solving for y, I'd multiply by 2 on both sides. I'd add 4 to both sides, and then I would divide by 6 on both sides. So when doing that, this is going to give me 2x plus 4 divided by 6 is going to be my final answer there. Inverse of f, again, if I were to jump a few steps, I've replaced f inverse of x, so replace this with y, and then swapping x and y, just direct find and replace. I end up with x equals 2y squared minus 4, and then I'm going to start by solving for y. Common area here to get screwed up is to try doing the square root first, where in reality we want to divide by 2 first. So we end up with this after dividing by 2 on both sides, and then my last step is to take the square root of both sides. So the inverse of f is big square root x plus 4 divided by 2, all underneath that square root there. Okay. G of f of x is the same thing as this, so I need to take f of x and plug it into g. And for this I was accepting really just the first step was really all that was needed. So if folks got here, then this is everything that I needed in terms of a right answer. So if I take a look, this is basically if I took f of x and then plugged it into that expression everywhere I see an x. And that's all that we had to do. So this is our correct answer. It can be simplified, but we don't really need to for our purposes. So here, first step, plug 4 into here. So this becomes 4 plus 2 squared. It's going to give me 36. If I plug -3 into there, -3 plus 2 squared, so that's -1 squared, which is going to give me 1. And then I need to find the inverse of h, which amounts to, again, jumping a few steps to get here. Then I'm going to square root both sides to get rid of that big square on my right hand side, and then finally subtract by 2. So my inverse should be this. And it's important to note kind of that radical only goes over the square root of x in that case. So that is our inverse function. That equals this. For what values of x would the function above be 16? So I can say 16 equals x plus 2 squared. If I square root both sides here, the important kind of point that we have with this is that we should have plus or minus 4 on this side. So I can consider positive 4 is x plus 2, and then negative 4 is x plus 2. And then if I solve both of those, subtract 2 on this side, I get x equals 2. Subtract 2 here, I'm going to get negative 6. If I take these x values that I've found and plug them into this equation, I find out that it is accurate, right? Negative 6 plus 2 is going to give me negative 4. When I square that, I get 16. 2 plus 2 is 4. When I square that, I get 16 as well. Proving the inverses here. So this would essentially be proving that both of these equal x. In order to do that, I'm going to take my initial function and plug it into my inverse. I then also need to prove that if I take my inverse and plug it into my function, that I get the same result. So on the left-hand side, I'm going to take h of x and plug it into my inverse everywhere I see an x, which is in that opening kind of spot. So this would look like this. And I need to basically make sure that this is going to equal x when all is said and done. So on my left-hand side, I have the square root of that expression squared. So I'm going to end up with just x plus 2 minus 2. And then those are going to cancel out, so I get x equals x. So that checks out. The right-hand side, I'm going to take my inverse and plug it into h of x. So I'm going to start writing h of x, but then when I need to write my first x, I'm actually just going to be writing my inverse expression. So this is my inverse expression, and I plug that into h of x. Here it's going to look a little different because my first step is actually to simplify the inside here. And again, I'm trying to prove that this equals x. And then this is pretty clear. These are going to cancel out, and I end up with x equals x. So this proves that we actually have the inverse function, which was requested of us. All right. We'll try to get through one more page here, and then we'll take a break on this particular video. Here, you could even start with these graphs, or start with these evaluations without even doing the piecewise function. Some people actually ran into a hard time because they used their piecewise function that they created to evaluate, and really we didn't have to. So f of negative 1 is this dot here. So f of negative 1 is just going to equal negative 1. We might confuse that with 1, but the closed circle is at negative 1, so that's what we're going to use. F of 2, if I take a look, is going to be given by this value. So just looking on my graph, I end up with that being 4. And then finally, f of 1 is right here. It's not even in a contentious spot, so it's not even in between two values. It's just going to be 1. Okay, so we can do all of those without even creating this piecewise function. If I need to create this piecewise function, the first equation I'm going to start with is this straight line here, which has a slope of 2. So it has a slope of 2, and it goes through this point, negative 1, negative 1. So if I use my equation right here for straight lines, I can say, okay, well then that equation needs to be 2x plus 1 minus 1 is my equation for that line, and it needs to go from, or anywhere x is less than or equal to negative 1 is the domain of that one. My next equation is a very basic x squared. It's not manipulated at all. And that equation is going to exist if x is greater than negative 1, or I'm going to say less than or equal to 2. 2 could be either equation if we take a look. They're both in the same location. So what I'm going to do is just choose one of those functions to give it to. So I gave it to the x squared, which means that when I arrive at my final equation, I'm not going to give it to that. So I'm not going to say that this is when x is greater than or equal to 2. This is also just the equation of a straight line at 4. using my graph below. So again, I might answer the questions underneath first. So for what values above does g of x equal 0? So that's going to be anywhere my graph hits this x-axis. So that's here and here. So I'm going to say that this is when x equals 2 or x equals 5. Different ways to report on that answer, but that's going to work fine. Value of g of 3 is kind of contentious. It's between those two, but my closed circle is going to indicate where this actually exists, so that's going to be at 5. And then here I need to find g of 2. So if I find g of 2, which is going to be this point here, g of 2 is 0. So now what I really need to find is g of 0, which if I go back to my graph, g of 0 is given right here, so g of 0 is going to equal 4. Just looking on the graph for the closed circle. Coming up with the equation for this, I'm starting off with a line coming in if x is less than 0, so this is just the equation of a horizontal line. Here I have a quadratic, which is in kind of the standard shape, but it's been shifted to the right by 2. So in order to shift something to the right, I need to have -2 attached to my x value. So this is going to be the equation of that graph, and that's going to exist if x is greater than or equal to 0 or less than 3, because I've got my open circle. And then finally, I need the equation of this line. So I know the slope of this line is 1, 2, 3, 4, 5, 1, 2. So m is -5/2. So make note of the fact that this is a negative slope. And then here, if we choose this point 5, 0, then I can end up just saying that this is x minus 5. And that's going to take care of that entire equation. And this is going to exist if x is greater than or equal to 3. Okay. So that is the first 2 pages of our assessment. I will post other videos for the other pages momentarily.